Hi, everybody. We will go ahead and get started. It is 3:30. I want to quickly introduce myself. My name is Erica Underwood, and I am the program director at the Data Incubator. We are a fellowship, scholarship, and placement program. So welcome. We have promised you guys a really great info session that will be led by one of our instructors, Michael Cullan. But to start things off, I'm just going to give you a quick overview of our program and everything that we do, and then Michael will jump in, and then we'll leave some time at the end for some questions you have. I want to just quickly let you guys know that this is going to be an hour session, so if we don't get to your question, which you can post in the chat channel or the Q&A throughout our talk, but if we don't get to your question, you can always email us at admissions@thedataincubator.com, and we'd be happy to help you. But that being said, let's go ahead and get started. So the Data Incubator focuses on training people to be data scientists. And why is that important? Why are we so into data science? It's really because it is the ability to work with the latest tools on unstructured and structured data to drive business value. This is obviously a big need in the world right now. We work with tons of companies from every different industry, ranging from tech, obviously, to finance, to healthcare, to retail. Every company these days has data and wants to use that data to drive value for them. And so why do we focus? What do we do that's a bit different? Obviously, there are a lot of other programs out there, so what do we focus on? Well, what we found is when you look at training, there's two different kinds of trainings, right? You can have a high, fast-paced, and efficient training, or you can have one that's a little bit slower but focuses on understanding and completion rates. You can see some examples there in the chart. University obviously is one where you're going to get a lot of understanding, but with a lot more time involved and invested. And with the on-the-job training, it's usually very quick and efficient, but maybe you're not really understanding what you're doing. So we've taken all of these aspects and combined them together to find a good middle ground of both of those things, where our program is fast-paced. You walk out of the program knowing a lot about data science and how to apply it in a real-world objective, but also with a deeper understanding as you get from university. As all of our students or all of our instructors are PhD and master's holders, they have gone through this program and they know how to give you that in-depth learning and training that you're looking for. So a little bit about our fellowship program. It's not your average program, as I kind of mentioned already. It is intense. That is that fast-paced schedule I was talking to. It's 9 to 5, Monday through Friday for 8 full weeks. It's very thorough. So each week focuses on a different aspect of data science or a different tool. In addition to our lectures, we do hands-on practice. So we really believe in a very interactive learning environment. So each week you'll work on a mini project that is associated with some topic of data science. Some of the topics we cover is TensorFlow. We do 2 weeks on machine learning. We do Spark, data visualization. Those are some of the topics that we cover in our program. Additionally, it's very collaborative. Again, with that hands-on approach, we want you guys to work with not only your colleagues and the instructors, but also work on presenting to companies. So part of our program is working on a capstone project that you have the opportunity to present to our hiring partner network. So you'll get feedback on how to present, how to create a capstone with a clear career objective, or not career, business objective. And it's a really great portfolio piece to add when you are interviewing for companies. Our program is very forward-thinking. We will have career coaches that help you with the career aspect of becoming a data scientist, not only learning how to become a data scientist, but getting a job in that field. So that involves work with your resume and your cover letter, interviewing skills, negotiation skills, all of that stuff. And then to help connect our students with our hiring partners, we also do a lot of virtual networking events. So we do partner panels where companies will come in and talk about what it looks like to work at a company, maybe what they're currently trying to tackle on their team. And we also do a pitch night, and that is where you can pitch your capstone project that you've been working on. We take in 2 types of students in our program. We have fellows Our fellows are offered tuition-free scholarships. We offer those to a very select group of people that are highly qualified and exceptional candidates. And they have to leave their program or leave a current position that they're in to attend our program and promise that they'll interview exclusively with our hiring partners. Scholars, on the other hand, must pay to participate in our program. That being said, they are not required to limit their career search within our network. They can look outside of it, but they still get access to the same curriculum, resources, tools, everything. So you'll still have everything that the fellows have, but then some flexibility to look outside of our network as well. With that being said, I think I'm going to kick it over to Michael. I think you guys have probably had enough about my intro. So Michael, please give them what they want, and then I'll come back on later and help answer some questions.
All right, thank you so much, Erica. If you could pass the screen share thing over to me.
Passing to you, but I think I have to stop sharing, so hold on, let me figure out how to do that.
Oh, all right, looks like it's been passed to me, so I should be able to start my share. Yep, content and Google Chrome. This should be sharing now. Cool. Okay, I'll return to this page in just a second, but sort of as a basic intro to what we're going to be doing today, I want to start by jumping off of a few things Erica mentioned about the fellowship. So really, I guess more with admissions. One of the things we ask you to do during the admissions process is to complete a coding challenge. Half of this is going to be sort of a classic computer science problem sort of challenge, a little probability or algorithms, sometimes more of like a math problem. And then the other half is typically going to involve some analysis of a real world data set. So today's demo is going to do a few different things. On the one hand, it's going to demo some of the tools that we use when we're writing these challenges, as well as when we are performing this type of exploratory and descriptive analysis. And then along the way, we'll also be talking about how do we think like a data scientist? How do we take a problem and turn it into something specific and something computable? And so we'll kind of be mixing these two, I guess weaving these two threads through today's demo, talking about the tools and techniques we use, and then also the way we think about basically what we do as data scientists. Now I'm going to try my best to pull up the chat window so I can send out a link to you guys. Let's see, chat. So let's see. This one. So hopefully you guys are able to follow through to this link. This is going to take you to the Jupyter Notebooks that we're going to be using. These are hosted through Binder. It's a great way to share Jupyter Notebooks sort of live online. That being said, also what you're seeing on my screen right now is a Jupyter Notebook. If you're not familiar, it's a great tool for writing and sharing interactive code, as well as nicely formatted markdown text. It's what I do most of my exploratory analysis in, and it's definitely a great tool for dealing with our data challenge, because it'll let you sort of work interactively. It'll let you document your work as you go, and still organize into something nice and complete and coherent and comprehensive at the end. So all that being said, again, this is a Jupyter Notebook. We're running interactive Python code here. If you navigate to this Binder page, I think it should take you to this page. You can press launch, and it should take you to another page that will open up, I guess, this server tab. So you'll see this Jupyter file browser. So if you do that, you're following along live, you'll be able to open up this first steps demo notebook. And I'll be running this from my own machine today, but you can certainly follow along in here. When you're in any of the cells, hold shift and press enter. It'll run that cell. You can also press this run button at the top. I tend to use the keyboard shortcut. And I'll just say, be sure to run these first 3 cells as I get started if you are following along. Especially this one right here, it is downloading the data we're using, and it kind of takes a little while. So, all right, that's the overhead. Let's actually get into it. We're starting today with a sort of broad business problem, which is very common, in the work of a data scientist. To take, not only a real-world problem, but also one that is at times ambiguous or vague, and try to, extract or locate sub-problems or, specific questions where we can actually derive some meaningful insights. So our hypothetical today, that we're working as a data scientist for a courier service, right? It's like a small-scale delivery service. Say we're operating in the New York City area, and they're asking us to help use data to make better deliveries, to plan their routes, figure out how they should strategize their warehousing operations, and all these sorts of things. And we're going to assume that we've been asked a very, very broad, very vague question. How can we better plan deliveries? How can we use data? And so, again, this is vague. That's kind of what we're going for here, because we want to talk about, not only how we get these numerical insights, but how we, find the questions that actually, when we're given a vague question, how do we find the right questions, for us to ask, essentially. So to start, we think about, there are a lot of, consumer level products, even just like Google Maps and Apple Maps, any number of them really, that give us directions from point A to point B. So if we're making deliveries, isn't that just going from point A to point B to point B to point C to point, and so forth? And not exactly, right? So we think about how the needs for this user are going to differ from the needs of a, consumer level user of a directions app. So, for one thing, we need to plan lots of deliveries at once. So we want to make sure that, it is convenient to get from the first to the second to the third delivery and so forth. And we also need to make sure we can get a certain number of packages in one day. And of course, you put those things together, we're not only thinking about the routes, but we're also thinking about what boxes end up on what trucks and all these sorts of things. So there's a lot, that has to be considered here. And in fact, there are applications that aren't just getting the directions. So, there's going to be a lot of angles that we have to attack this. But we'll start with, a specific example or component of this as we start going towards proof of concept, just thinking about the actual routes, that we should be taking. So if we're asking, how can we plan a good route? Now we have to differentiate what is a good route in this case. How is that different from just typically a good route for a consumer level user? Of course, we want to make sure they're delivering things that are closely packed together. There's no sense, again, if we're operating in New York, let's say, there's no sense having somebody go from the Upper East Side down to Soho, perhaps to Fidei, back up to the East Village and just going all over the island like that. We want to make sure they're, dealing with a relatively small area, and even within that area, taking a short route from place to place to place. Of course, we want them to be fast routes. That's kind of always the case. We also want them to be reliable, right? We don't want to have a high risk of, some particular route we take being, plagued with accidents or, sort of weird, unpredictable events that could make it difficult for us to estimate how many deliveries we can make in one day. So reliability is great for us here as well. As I've been starting to enumerate here, again, there's a lot that we might have to do to really solve this problem or to really get, comprehensive insights. We're just kind of getting the process started here. So of course, we're not going to get into machine learning. We're not going to be implementing anything in real software, but we're just going to show, what this exploratory analysis process looks like. And so when we start, as we likely should as data scientists, with some data. In thinking about those components of good routes, we can sort of think, okay, well, we want to know where we are and where we're going. So, some representation of a map of New York City would be great. So I'm going to open this up. We'll take a look at these in just a moment. We want to know a couple things about traffic within the city. So I've located some data sets and APIs on that as well, made free and public by the City of New York. Also a real-time API So if we wanted to integrate something into software later, we could actually get real-time traffic data, super cool. And talking about, reliability, we might want to know, again, like if a particular street is prone to accidents that might cause, major traffic delays. So we might want to start learning something about, what the patterns of automobile collisions look like in the city. Navigate through these for just a second. This is through the NYC Open Data Project. They have a lot of really, really, wonderful data sets that you can play around with, collected just by sort of, public service departments and so forth. So we have this map. We could export this if we wanted to in a number of geospatial formats, CSV as well. We're not going to touch this for today. This is just to show you some of the resources we have available. Likewise, for this traffic data set, we also get some metadata here so we can see how many rows and columns we have. We can get a preview of the columns, a preview of the data set as a table. Again, a lot of good stuff on this website on the Open Data Project. Again, we're going to not use this data set for today. We're going to stick with motor vehicle collisions, but just, again, kind of a survey of what's available on this platform. So it's going to be our data set. Collisions in New York City, over 1.5 million of them. There's going to be 29 different columns. We'll see those in a second. And we see that this is getting updated very frequently. So this is actually going as recently as like last Friday, I suppose. And so that's kind of the data we're going to be working with. At the top here, we downloaded that collisions CSV. So we should be good to go. And I'm going to start running some of these cells to get the data loaded up and so that we can start taking a look at it. Now, because we're doing proof of concept here and because there's a lot of data, right, 1.5 million rows there, I figure maybe let's not look at the entire city, but let's start by restricting to Manhattan, where we can imagine many of our deliveries, would be occurring anyway. So I'm going to take the data, I'm going to restrict it to Manhattan, and we can start taking a look at our table from there. Now, what are we looking at here? What library am I working with? This is something called Pandas, which we see here aliased as PD. This is sort of Python's answer to, data frames in R. In some ways, Python's answer to, extending past Microsoft Excel, working mostly with tabular data, in 2 dimensions, columns and rows. Also, how Python often integrates with SQL, doing exploratory analysis on SQL queries and so forth. So again, this is Pandas. We use this a lot at the Data Incubator. This is one of the primary tools we work with, especially for exploratory and descriptive analysis, and is very, very common in industry kind of in general. So if you're looking for the right tools for the job when it comes to the data challenge, I very highly recommend Pandas. Not for nothing, when I write these challenges, certainly, I typically am, performing my initial analyses and developing and computing answers in Pandas. So you could do worse than to use this tool. I, again, highly recommend it in general, recommend it for the challenge as well. So it's a little bit on Pandas. So again, we've restricted so that we only have collisions happening in Manhattan. And now we're just looking at a quick preview. So we have things like the date and time of a crash occurring. We know that it's in Manhattan, of course. We have the zip code, latitude, longitude. We also have the on street and the cross street. So, what street did the crash happen on? What intersection is it near, right? And we can see a number of other things. So we see, what was contributing to this crash, what sorts of vehicles were involved, and all these sorts of different columns. So from here, let's start getting into how we can use this data to answer meaningful questions. One thing that I'd like to start off by doing, rather than having 2 separate columns for date and time, it would be much more reasonable in Pandas to turn these into an actual date-time object. And to do that, we're first going to combine those 2 columns together and then convert them to something that is actually an object we can use as a real sort of temporal data point. So I'm going to do that down here, just defining this new column timestamp. And this is going to be just that crash date, a string, so we're going to take that date, a little space in between them, and then the time, and then we're going to make this timestamp, or then we're going to convert that column to a date time object. And we can do things like resample daily, or we can get just the hour of that time, all of these sorts of things in an object-oriented way. So just getting those timestamps. And while that runs, I want to point out something I'm doing down here, which is that I've written this function, make timestamp column, that you notice just does the same thing that's written in these two cells above. The reason I do this is that I would recommend this in general, and again, for the challenge, taking the, the necessary computations you're doing, basically all of the transformations in your analysis, wrapping those into functions, I very, very highly recommend for a few reasons. One, working in an interactive environment like a Jupyter Notebook, it's very easy to sort of get out of order. I might, start running some code. I might make some new cells up above here. I might say, oh, well, let's look at, the timestamp, and then let's just look at, the hour that these things were happening, and now I can see the hours. But as a result, if I reran this notebook, now I don't have timestamp because I'm going, I haven't run this cell yet. So you can get really out of order in a Jupyter Notebook, and the more you wrap things into functions, the more it's clear, what's happening in every individual cell, and the more efficiently you can put together reproducible workflows. By the same token, if we wanted to go back through and perform all the same analyses on, let's say, all of the crashes in Brooklyn or the Bronx or all of them in the city in general, the more we have things, modularized into functions like this, the more easily we'll be able to do that. So just to get another note on how to organize your work. So now we have that timestamp column. We'll revisit that, the utility for that later. But another thing we certainly want to do as we start, probing through our data set is looking if we have missing values. So making use of this ISSA method here in Pandas. This is going to give us a new table just saying for a particular row and column, do we have a value there? True, yes we do. False, no we don't. So this shows us, kind of at the cell by cell level, but let's see maybe at the, at the column level, what proportion of values are missing. This is what we're doing down here, just the first few columns, and then what we're doing next is, let's put in descending order, what columns do we have the least values for? So here we see for like vehicle number 5, almost 100% of these are missing. Looking down at like vehicle number 2, that's much lower. Now we might start thinking maybe that means that understandably not all automobile collisions have 5 vehicles in them. And that's represented, in a missing value sort of way in our data. We'll think about that later as well. Notice that we, don't always have the on-street and the cross-street names. We notice that we more typically have location, latitude, and longitude, not all the time, but pretty often. We also notice that we always have, these columns down here. This gives us some insights into how this data might be collected, what is a required field, what it's not, and all of these are, meaningful for different questions we want to ask, answers we hope to find. But again, we're just seeing the proportion of missing values. I'll also note, as I'm going through this, I would love to get into, how each of these individual blocks of code works, and essentially in the process teach Pandas, but we have a pretty limited amount of time here, so kind of keeping things a little bit more broad. But because you can, navigate through this notebook yourself in Binder, you can certainly explore the code a little bit more on your own. Okay. So we've done a little bit of initial probing for missing values. We've created that timestamp column. Now let's start getting closer towards, the questions we really want to ask. We're going to do a little bit more filtering first, though. The data we have right now is all crashes 24 hours a day, 7 days a week. This is perhaps not that meaningful for us because, we have a specific business case here, which is planning routes for this courier company. And as a result, we probably don't care what happens on a particular stretch of road at 2 or 3 in the morning. Probably more interesting to us if something happens maybe between 8 a.m. and 8 p.m. Perhaps we only deliver till 5, perhaps we go till 10, but some sort of, delivery window that we'd like to restrict our analysis to. So to do this, I've written this function, filter delivery hours. We're going to pass in our data frame. We're going to get a data frame back out that is filtered based on some starting points and some stopping points. So we have 8 a.m., we have 8 p.m., of course, on a 24-hour clock. That's going to be 20. And this will transform our data frame so that it only has crashes happening in that window. So we can run that here. And then from there, we're just going to make a little histogram of, the hours that these collisions occur. Unsurprisingly, it looks like a lot of them are kind of going to be around, at least morning rush hour. A lot of them happening between 8 and 9. It's like we have a fair number of them happening, I guess, probably between 2 and 3. We have some more happening, later at night. It starts getting dark. But again, just doing some basic analysis or basic exploration, looking at this quick histogram, lets us just, again, probe the data a little bit more, just do a quick sanity check, see if the patterns are, seem reasonable, or if maybe we uncover interesting information we want to get into more. So there we're filtering, again, making use of functions so that we have clear and reproducible workflows, and a little bit of visualization along the way. Now we can start doing things a little bit more interesting. If we're planning these routes, we have to think that we would like to have, information on collisions that is sort of relevant to how we get through a city. Of course, that means navigating through and, turning at intersections, for one thing. So although we had that location column, and that was like latitude, longitude coordinates, and we had that for a lot of our rows, that doesn't tell us a whole lot in terms of, how we actually navigate through Manhattan in this case. So instead, we're going to take that on-street and that cross-street column. We're going to use those to create a feature for intersection. And then that can start telling us a little bit more about particular, parts of the city, parts of the, the grid, I suppose, that we might want to avoid. So again, we are writing a function to make intersections. It's going to snap those two columns together into a new intersection column. So we're doing that right here. We can take a look at our data frame with the intersections. I'm calling .head to get the first 5 rows of the data frame. Scroll all the way to the right. We now have this intersection feature. So we have this one that happened on East 79th and Park. And all this is really done, again, is to combine these two columns together, but in a way that is meaningful for us because, we do want to know where these things are really happening. I'll also note that we made these into a longer string here, rather than putting them, let's say, into a tuple of strings or a list of strings, and we'll see why that's useful for us in a few minutes as well. But from here, we have, enough information to, let's say, look at what are the, the most dangerous intersections. Where do we see the, let's say, the top 20 intersections that have the most collisions, and how many collisions, do we count in the data? Unsurprisingly, I have a function for that as well. So here, passing in our data frame, and I'm saying, all right, so our top 20 intersections, by the number of crashes, we're just going to take that, series of intersections, and we're just going to count up all the values, put them in descending order, and take the top 20 of them. Again, pretty unsurprising. And we get this series out that tells us, clearly we have a lot going on in, Midtown. Pretty unsurprising. A lot of these are, really looking like that area. Some stuff a little bit further downtown, some stuff up in Harlem, but, not that that really matters for our context, but we can, now see what intersections we actually care about. I will also say here, don't know if these, I will also say, and this remains to be seen, intersection for us is ordered, right? These ones are on 11th Avenue with an off street of West 40th Street. These ones are on West 40th with an off street of 11th Avenue. Maybe we want to do it that way. Maybe we don't want it to be ordered, but in this case, we have chosen to think of those as separate things because they may influence, driving behavior if we're going down 40th Street versus if we're going down 11th Avenue. So we've kept those separate here. But when we make features like this, we have to keep these sorts of things in mind. So again, combining two features to make a new one, using that to get this kind of nice descriptive chunk of descriptive analysis, making use of functions all along the way. But we can also get a little bit more interesting. All we've done so far really is manipulate, move around existing features, none of which is very unique to Pandas, unique to these more advanced programmatic tools. So we're going to start doing some feature extraction and some feature engineering. And by feature extraction, what do we mean? Well, we're taking something like this, which we know has some information in it that we might be interested in that string, but which we have to sort of get out in a non-trivial way. So for instance, I might want to get a numerical representation of whatever street we happen to be on. So if we have East 125th Street, I might actually want a column that's that number 125. Might be useful for me to look at a chunk of the grid, for instance, north to south, everything between, let's say, 125th and 155th, something like that. And so Pandas, of course, let us do this as well, writing another function. And in here, I'm using a regular expression that's going to look for something that kind of looks like some number of digits and then a space and then st street. And if it finds that, it's going to pull out those numbers. So we're going to extract those. We're going to get this series from those. And we're going to assign those to be a new part of our data frame. And so now we look at our data frame. And we go all the way to the right. We see now we have this street number column. So this one was on East 79th Street, and we have 79 in that column. Note also that this one had an off street of West 160th Street. We still recorded that as well. Again, a conscious choice we made that we just want to know the closest street number, not worried about whether it's the on street or the cross street. We could have done that differently. It would have had implications on our analysis. But that's getting those numbers for us. Using regex, something that we do cover in the fellowship, to extract information from text based on some kind of pattern. Somebody asked why we're using a floating point value for the street number. Fantastic question, because we would imagine there's probably no 79th and 79.125 street. I suppose St. Mark's in the East Village is something like a 7.5 street, totally beside the point. But the reason we're doing that is because in some cases, this is going to record not a number for us. Here, there was no street list or no street number listed, so we couldn't extract that value. And to convert to an integer, we couldn't have this type of null value. We could have replaced it with something else, perhaps a -1. We could have replaced it with a none rather than a not a number value, but we just left it as a floating point here. So now that I have this street number column, I'm going to create a filter, a boolean mask, basically, that's going to say, give me a whole bunch of true and false based on whether this number is between 1 and 14. So I'm looking at, a little particular chunk of downtown here. Inclusive is true, so this does include 1st Street, does include 14th Street. And this is giving us all of these. I'll take a look really quick. 1 and 14, true and false. We could even look at, out of these, looks like only about 4% of them are in that chunk, but in any case, that's going to let us filter onto only streets in that area. So now we take our original data frame, we filter using that sort of series of true and false values. We grab the intersections once again, and now we look at the top 10 most dangerous intersections. And it looks like, perhaps unsurprisingly, if you're familiar with the city, every single one of these has to do with 14th Street. Doesn't surprise me very much. Maybe this isn't that interesting to us, though, since it is perhaps sort of obvious. So maybe we'll try this again, looking inclusively between 1st and 13th Street. Certainly do that. And now we're seeing Perhaps the Avenue of the Americas is showing up a lot more, but in any case, again, what we're doing here is we're performing some, regex-based feature extraction. It's sort of maybe closer to feature engineering, and it's letting us filter our data in a much more interesting way to, sort of get more meaningful, reduced views of our data. We could imagine if we really started putting this to work, mapping out things like neighborhoods, using this to define chunks of the grid that might be more meaningful to us. But this is really just a very basic proof of concept. Just to show the power of regex, I have another example right here that we're also going to turn into maybe a slightly more sophisticated feature. We're going to look at a chunk of, streets that run north to south, avenues A, Avenue D, which, along with a sort of north and south boundary defined part of Manhattan called Alphabet City. So again, we have those intersections. We're pulling out something that looks like avenue and then some letter between A and D. And if we find it, we're going to extract it. And we have that wrapped in that function. So here, after getting rid of our missing values, we see that these just look like what we expect. Avenue A, B, C, and D is going to be in there too. Somebody mentioned, why did we look at the mean for between 1 and 14? So this, we look at this again, was a bunch of true and false values. So looking at the mean is like saying false is 0, true is 1. How many of them are true? So this tells us that about 4% of our collisions occurred, with some on-street or cross-street between 1st and 14th Street. Answer the question in the chat. Okay. So we've pulled out this new feature, avenue, for these lettered avenues, avenues A through D. And we're going to see, and I suppose we need to actually, we're going to take that and we're going to, reinsert that into our data. So now we have not a new column for it, but we filtered based on, whether they have those lettered, those avenue A through D street names, the new data frame for that. Now within here, we can see, in here, what are the most dangerous intersections. Now we see a lot of them are happening on Houston, perhaps unsurprising again if you know the neighborhood. But this is just to show once more some of the types of manipulations we can do in Pandas as compared to more traditional tools. One more quick example. We noticed that we had these 5 columns for the types of vehicles: a sedan, a taxi, SUV. We're going to use this because we have all these missing values. To create a new column saying how many vehicles were in the collision. So here we have a sedan and a taxi. These 3 are missing, so we have 2 vehicles. So we basically check, is that value there? Turns it into true and false. We can just use that to count up. So I'm writing another function here, get number of vehicles, and just kind of show how this kind of works. Again, it takes all those columns, checks if the values are there, adds them up, and makes a new data frame of the number of vehicles per crash. So we run that, and we can take a look, and we find that, perhaps unsurprisingly, most collisions have 2 vehicles in them. 1 vehicle collision shortly behind, but we get a sense again of just the shape of the patterns that we're working with. And that's a little bit of feature engineering. And we'll bring this back into our original data frame. So now we have that column all around the right. And if we wanted to, we'll try this out here. We could look at, okay, so for those top 20 most dangerous intersections, what's the mean number of vehicles, for a collision in that intersection? Could be the case that some intersections we are more likely to see, a different number of vehicles. From our analysis here, it looks like it's not very likely the case. Some statistical testing might tell us that these are significantly different. For some of them, they may not. but it is just to show, some of the other feature engineering we can do, some of the other, aggregation that we can do. We could imagine a number of other uses for this, however. We could split this by time of day. Combining this with a traffic data set, we could look at, the time it takes to clear up multi-vehicle accidents, how that affects, our route planning and so forth. But this is all just kind of a quick overview. So again, what we've covered today, I'll scroll back up and kind of just take a quick lap through it again. Taking this very vague problem, how can we better plan deliveries? Looking at some more specific angles in there that we could try to attack, and then finding some data, and then doing some quick exploration. Along the way, using Pandas, using Jupyter Notebooks, wrapping relevant code into functions. I highly recommend this in general, highly recommend it for our data challenge. And then just kind of going along and, performing some interesting and hopefully meaningful, analyses as we went through. Super quick introduction to, exploratory data science analysis, to Pandas, to Jupyter Notebooks. Again, I wish I could, take longer. You can probably tell, but I could talk about this all day if I really wanted to. Or I guess if I really could, but that's just a quick overview. So what happens next? Talk a little bit about, reproducing and sharing this. I directed you guys to this binder link at the very beginning. This is a great way to use an interactive notebook online. When you share Jupyter Notebooks and GitHub, they're just PDFs. You can't run them interactively. Highly recommend this. Again, that's binder. mybinder.org is how you share those, just from a GitHub repo. I will also note that, if you would like to, and that container is no longer live, but I'll show you here. From that binder link that I sent out, and I'll paste it as I close out as well, but if you'd like to download anything, perhaps this won't show from here either, you certainly can download either from the binder link or from the GitHub repo I hosted this on. I'll paste both in the chat to keep looking at the code and keep working. And of course, and something just to think about as you go on, how can we start applying these analyses and other analyses back to that original problem of planning better routes? Again, something I'd love to talk about all day, but I really should at this point take just a few quick questions, probably 2 or 3 quick questions, and then pass things back to Erica, who has more info on the fellowship. So one of these in the chat mentioned, can you use other languages as well? Stata, R, SAS, others. We certainly see people use a lot of different languages. R is very common, of course, coming out of academia. And we don't penalize people in any way for using other languages. We don't give a preference for any of them. I would say write what you're most comfortable in. Write what you can produce the most, expressive, readable, and correct code in. But you certainly are allowed to write it in just about anything. Someone also asked, how do we decide about these dangerous intersections? We didn't really have a threshold here. Just looking at, where the most collisions occurred and looking at the top 20. Now, we could have set a number of rules for what makes a dangerous intersection. Could have done X number of crashes per day, per week, per month, any number of ways we could approach this. And there's time for maybe one more question if there are any others. Otherwise, I'll pass things back to Erica, see if there are any other ones floating around in the chat. It looks like there is not. Also, it looks like I may not have had my video on this whole time. So apologies for that. I usually do that when I do screen shares. But in any case, hello, everybody. I'm Michael, one of our instructors. So last question I'll field, are there more data science applications we can work on to get their hands dirty in some repo? Regarding applications, I would recommend, if you mean like these sorts of interfaces, I would recommend Jupyter Notebook and Binder. Jupyter Lab also if you like something closer to RStudio. you also can, find a lot of data sets through things like NYC Open Data, but, also through just resources like Kaggle as well, a lot of, public data sets. We have some more technical questions coming in, addressing null values, multiple testing, all these sorts of things. We get very technical, would love to talk more about them, but this is a very, very quick and dirty overview, looking for usable signal rather than going straight towards extremely, rigorous testing, protocols and so forth. All right, well, that is it for me. Thank you, everybody, for, for sticking around, and hopefully this was instructive, interesting as well. And I'm going to pass things back to Erica. So if I stop sharing and if I drag this like this, you should have screen share capabilities now, Erica. Looks like the PowerPoint is back up.
Yep, I think we're good. And Michael, you were on for a little bit, but then, you had to turn your camera off so you could really focus on the content. So I don't think anybody blames you. All right, guys, I'm going to pick up a little bit. I've been answering some questions on the Q&A in the chat, but I'm going to just pick up a little bit on where we left off, hopefully answer a couple more, and then we will wrap things up. So the big component about our program that we really pride ourselves in is helping our students not only grasp data science, but get placed in that field, right? So 97% of the students that go through our program are currently employed outside of academia, and 82% of them are employed within 6 months of completing our program. Those are really great numbers. We're very proud of those. We work very hard for those. And that's part of the challenge, right? Not just learning the content, but being able to transition into a data science role. And that's really where our program is great, because we help you do both. Where are our graduates working and what are they doing? Well, our graduates are working in 55 different industries. I kind of mentioned a lot of those in the beginning, that data science is in a lot of different companies. But primarily, we see a lot of our students going into computer science. That makes sense. Internet, information technology, of course, financial services. A lot of students go into biotech. What are the typical job titles that our students are in? Again, that varies depending on company and industry, but you can see over there that most of them are getting placed in a true data science role, but we also place data engineer, data analyst, quants. Some people go into maybe like a research scientist or a machine learning engineer. All of those are titles that we have placed in the past. Here is just a very short list of our extensive hiring partners. I will mention that if you are interested in seeing a list of our hiring partners, you can email us at admissions@thedataincubator.com, and we'd be happy to share some of that with you. And many of you were asking, okay, if I get into the program as a scholar, do you guys provide financial assistance? And the answer is yes, we do, especially in times like these. It's hard because a lot of people have extra time and a really great time to participate in our program, but maybe not as much cash flow as they'd like. So we want to help you with that. So we have partnered with Leaf, and we provide an income sharing agreement. It's great. Essentially, you can participate in our program with just a deposit down, and then you pay once you get placed in a job where you're making over $40,000 a year. We also do provide loans through Climb Credit. These loans can also cover any relocation fees or housing fees if you need some help there. And then also STILT offers loans for international students. So I know we have some students that are looking to participate in our program that do not have a U.S. Social Security number, and so STILT is a great way to find help if you're in that situation. So where are we at right now? Well, we do 4 cohorts a year. So we actually are getting ready to start next week our summer cohort, but our application is open currently for our fall cohort. Our fall cohort is going to run from September 21st through November 13th. As I mentioned before, it's 8 weeks long. And great news is our application is still open and the deadline is July 3rd. So you have a little bit more than a week to submit your application. A couple questions about the specifics there. Our application, we ask that you submit the actual application by July 3rd. You'll then have 72 hours to complete the challenge, so the challenge deadline will close July 6th. You cannot complete the challenge unless you submit an application. So make sure you submit an application. Just in general, I recommend doing it sooner rather than later. You don't want to have any glitches and be behind because unfortunately we cannot open up that deadline. That is a true deadline. So that's for our early admissions. We also do regular admissions after that early admissions. What's the difference? Well, we really evaluate candidates on a first come, first serve. So if you want to have a better chance of perhaps getting a fellow spot, or just even knowing if you make it into the program earlier and having a bit more time to come up with finances and such, I absolutely recommend applying for that early admissions application. That's going to help you. You guys are going to know sooner that you got into the program and you're going to know things. And I think that's it. So you can apply if you're interested in applying our program. I hope you do. You can go to thedataincubator.com/apply and apply there. If you have any questions about your specific situation or anything about this presentation or going through our application process or anything, please reach out to us at admissions@thedataincubator.com. We'd be happy to answer your questions. So I think that's really all I have to say about our program. I'd like to pop over to the chat and the questions, see if we have any. Michael, do you want to maybe jump on and see if there's any for you, or maybe help answer some of the questions that I get?
Certainly. So I'll see if anything else is any other like really solid questions. I see some other ones coming up in the chat. They're a little bit more specific, a little bit more like particularly technical. Some people are asking for GitHub and Binder URLs one more time though, so I'll paste those right now.
Yeah. Also, some people are asking if we're recording this. We are. In the next day or so, we'll send you an email with this recording, so you will have all this information. Another question we got to just address how we're handling COVID. So our spring and our summer session that we're getting ready to start have been moved online entirely. Just for the safety of all of our students and our staff, we just felt like we should do that. We have decided, because things are still up in the air, that we are going to move our fall cohort entirely online too. Again, your guys' safety is our biggest priority, so we just want everybody to be safe. The good news with that is that we have been teaching an online cohort since we started our program. So we are used to teaching online, especially since this is our third. The fall cohort will be our third cohort that we will teach in COVID times. So we are continually improving our methods and trying to create not only a really interactive learning environment online, but also a fun one. We're doing some social virtual happy hours and events. All of our partner events still take place just virtually. And actually, we've seen an uptick in participation because it's easier for people to get there when it's online. So everything is relatively the same, just online, again, for everybody's safety. Typically, our fellow spots are reserved for in-person. Of course, since we are doing everything online, we are doing online fellows right now. I don't know where we're going to be at in 2021. I hope we have the opportunity to do it in person, but that's just still going to be on a TBD basis, and we'll continue to monitor and see how things are going. But for now, our fall cohort will be entirely online. Somebody's asking if an ISSA is available for U.S. citizens. You have to have a U.S. Social Security number. I know there are some visas or some people that maybe aren't a U.S. citizen but have a U.S. Social Security. So as long as you have that, you can apply. I'm trying to look through and see if there's anything else I missed. Lots of questions about visa status. Of course, we have to take that on individual basis. So if you have any specific questions about your visa status or if you're able to apply to our program, please email us at admissions@thedataincubator.com. That being said, I mean, most of the visas that most of our hiring partners are located in the U.S. So, you know, we work with a lot of students that are F1, that are on their OPT or CPT. We work with a lot of TN visas. We work with some H-1Bs. So all of those visas we've had students have, so that's usually not a problem. But again, you know, hard to say, lump them all together, so you can always email us for your specific questions. Let's see. I think that's it. Just want to remind everybody again to apply, hopefully for early admissions. The application is due July 3rd. So make sure you get that in, and then you will have 72 hours to complete the challenge. So the challenge will shut off at 11:59 p.m. UTC on July 6th. Don't forget that time zone. That throws people off. Again, just to be safe, just go ahead and start the application now so you don't run into any of that. If you start the challenge and you have some questions, again, you can always email us at admissions@thedataincubator.com. I think I'm going to answer a couple more questions. One more question about how our program is structured. So our program is considered a full-time program. It's 8 weeks long, and it's 9 to 5 every day. We do offer it in 2 different time zones, Eastern Standard and Pacific. And we do require all of our students to be in the live sessions. Online, I should say. And so if there's a lecture, if you're doing office hours or group meetings, we do require you guys to be there. That being said, we totally understand that things come up, doctor's appointments, life events, so we do record them, but they are not to be used, you know, on a consistent basis. We do want you there live, virtually, and interacting with students and the instructors. That's where you get the most out of the program and learn the most. So as far as requirements are concerned, education-wise, we do require that everybody has a bachelor's degree, and you either have to have a master's or a PhD or be working towards a master's or a PhD program. So somebody's asking, does the challenge start as soon as I register or on July 4th? Great question. So once you complete your application, once you submit that, you will get an email and you can start your challenge at any point. So you could submit an application today and you could decide you're going to start your challenge in a day or two. We did that because we want you guys to have the time to schedule to, you know, do it. We don't want it to be at an inconvenient time for you. That being said, it will close for everybody on July 6th at 11:59 p.m. So even if you have some extra time left, that is the deadline hardcore. So you have to make sure that you start the challenge before that deadline and to ensure that you will have all of the time to complete that challenge. And you get to decide when you start that challenge. Does that make sense? You don't have to be a student. Most of our students that come into our program have just wrapped up their PhD or just graduated with their master's and are looking to transition from academia into the private sector. Or we have a lot of students that are working, either they're in finance or maybe they're, you know, doing some software engineering type work, more back end, and they want to transition into the data science world. And so they have maybe a year or two of work. But most of our students are ready to be placed into a full-time job. So they have completed and wrapped up their academic work to some degree. So if you are going to apply for regular admissions, you do have time to complete that challenge. You can find all the deadlines on our website, so you'll be able to see the actual challenge deadline for the regular admissions. These dates up here are only reflective of your early admissions. All right. With that, I think that wraps things up. If I missed your question or if there's something that you didn't get a chance to ask, please feel free again to email us at admissions@thedataincubator.com. But thank you so much for joining us today. We're so excited to have you guys. We hope to see you this fall. And Michael, thank you so much for your time and the information. And this is recorded, and you'll get an email from us with all of this information in it. So without that, I will tell you guys goodbye and hope you have a wonderful day.
And thanks again, and bye everybody from me as well.